So hi everyone, so this is the CTF challenge walkthrough for CSAW CTF. So this slide is pretty short and there is only two agenda for today, which is challenge walkthrough and Q&A. So let's get started. Okay. So these four are the challenges we will be going to walk through, and we will start from the easiest one, which is the rebug one. And for this challenge, it has been given a file called test.out, and already I opened it in the IDA, and this is the main function of the binary. So looking at the binary, it looks like it's asking for a string, and then this for loop is actually looping all of the character of the string, and then yeah, basically after that you check the I, which is the string length. So this input. So this also means that our input length must be equal to 12, and if it's 12, then it just say it's correct. And then this EVP function, I believe is open SSL function, and looks like it's getting the MD5 sum of the 12 string and then just print it out as flag. So we can verify our guess over here using the Kali machine. So this so for input string must be length of 12. So 1, 2, 3, 4, 5, 6. Yeah, so you can see our so it just print out the fact. We can also test that whether this hash string is the MD5 sum of 12. So as you can see, it is indeed. So yeah, that's it for challenge 1. So let me close this out. Moving on to the next challenge, rebug 2. So for rebug 2, the main function first is copy our string into v4, wherever we don't know what is it yet, and then it directly just print out this incorrect, right? And then underneath it looks like we're calling this print bin character, and then based on what this function name is, I believe it's just printing the binary of the character we input. No, there's no input for this binary, so looks like it's just printing out the binary of v4, which the string over here. And it also perform a SOR function maybe, and you can see like in this for loop, it assigning 0 or 1 to the flag variable. Yeah, so what we can do is we can try run this binary. Let's see. I see it immediately says this is incorrect and no flag, and it's not asking us for input. So for this challenge, actually it want to test our debugging skill. So what we did is we need to get the memory address of this flag, and then just set breakpoint right before this binary return, right before this binary exit. So the exit is at here, which is 131E. So we can go back to our Kali, GDB CTF, right? 131E. And then the next thing is need to get this address of this flag. So it as over here. So this 11DD. So and then we just run it, and this is the address of our flag we need to get. You can see it's empty now, but if it continue till the end, it's still breaking in this. So we can delete the delete the breakpoint first, then it's continue, and then if we view the flag content again, you get this value, and this is actually the flag. So during the competition, I try to maybe convert this into something meaningful English word, but turns out this is exactly the flag, right? So yeah, it is what it is. So next to the third challenge, which is my favorite one among the four. So let me close this out. So this challenge is called Impossible Brawler, and this is actually a game hacking challenge using the Go engine. You can see the file description over here, Go engine. And actually this application is a loader, and this PCK is the, you can think of it like the game logic. All the game logic access is in this file. And we can try run this game. So you can see when I try to hit enemy, right, his health is not decreasing at all. So there's no way we can beat all these enemies. Yeah, I can see his health is not decreasing, and we need to kill all the enemies, right, to get to the next level or something like that, get a flag or something like that. So we can close this out, and I found two tools that can help us. First is this GDRE tools. It is in let's see, it's in a GitHub report called GDS-decom. And then the next thing is this go.pck tool. Is I will explain why I need these two tools later. First, you open up this go.reverse tool. Then we need to recover the project, and we can choose the PCK file, and we can dump it into a folder. Let's call it dump. And select and then extract. So what it does is the pack is like compressed file, so we need to extract it. Yeah, something like that. And looking at the dump file, this is all the information we have. And the files end with GD is actually the scripting language, I would say, for the Go language. So the important game logic lies in this scripts directory. So we can open our Sublime and then open the folder. Okay, so we can first look at the player.gd file. So you can see the working speed. Our working speed is 450. We can change to 4500 just to prove our concept. And the next thing is we need to pack this. After you modify the file, right, we need to pack again all this file in this dump directory into the PCK file, right, in order to load it correctly. And these two actually provide a feature to pack it into PCK file, but I found it will fail throughout the process. I'm not really sure why, but then I found this go.pck2, which will work for our case to pack the dump directory into the correct PCK file. Yeah. So let me open my command prompt and power over to the desktop. Then we can see we can run this go.pck2, and then I will just follow the instruction on its GitHub page, which we are going to have this file name. Yeah, also this PCK file name must same as this application, so we need to provide the same name. And then -a is stand for adding, I think it's adding, and then the directory of the dump file, dump folder, and then remove prefix. So if you run it and then it's done, and then you get this PCK file, we can rename our original to something else first, and then move this over here. Now if you see, when we execute this game, our move speed will be increased a lot. So you can see basically like flashing. Yeah. So our theory is proven. Now we can try solve this challenge. So looking at the script file, like, we got level 1 and level 2. This is definitely interesting for us, and basically we need to solve this. So the first level 1, we can see that it checks for enemies left is equal to 0, and then it will calculate calculate a seed for random library, and then change to level 2, something like that. So, and then in level 2, it will check again whether the enemies left is equal to 0, and then it will get some value random, and then print out as a flag, right? So what we can do is we can change this to bigger than 0, and then level 2 also bigger than 0. So by that, we modify the game logic so that when we launch the game, the enemies left will definitely bigger than 0, and then we will win the game immediately. So let me pack this again, and then close this out, and then copy this over here, replace. So when we launch the game again, yeah, I can see the flag is appearing right above us. So that's it. That's the flag for game for the challenge number 3. So moving on to the last challenge. The last challenge is actually not that hard. It's just that it's compiled in other environment where we need to set up the environment to debug the binary. So let me open the detect it easy. Let's give it a second. Uh, It's okay, it's open. So you can see the operating system this binary is compiled in is in FreeBSD. So we need to set up the FreeBSD environment to debug it if you want to. And you can first analyze it statically. So opening the binary in IDEA Pro, we can see that in the main function, it checks for arguments greater than 1. If it's not, it will just print out the help menu. So all these standard library actually the C++ thing. We don't need to care about it. We just need to care the core function which will verify. And then under this function, we can analyze it now by looking at it. So first of all, copy some string value into this v28. We're not yet sure what's it, but it's okay. And then we need to make sure that this is our input. So our input, and then it will check. Yeah. So this for loop, it seems complex, but it's actually it just XOR our input with the value. Yeah, with this value. So we can say this is something like key. Yeah, just give it a meaningful name. Yeah, so this entire for loop is just XOR our input with the key value up here. And then the next for loop is doing calculate something and then getting value, getting indexes value from our input, and then it perform XOR again with the v27, which is the output of the first for loop. So okay, that's still okay for us. The thing is, we do know this the value of data. So this data value is in PSS session, which means it will only initialize in runtime. So we need to debug it eventually for this binary. Okay, we can keep that in our back of mind. The next for loop is also the SOR something, and then yeah, just SOR something. I think it's also based on the result of the second for loop. So the second for loop based on first based on the SOR with our input with key, and then third based on the result of second for loop. And then down here is checking our, this is a CT, you can say the ciphertext, where it will check the result of our third for loop with this CT ciphertext. So so what this program is eventually doing is we need to input something, and the string we input will eventually go through all these 3 for loops, and then eventually it must become to this string so that we will get the flag, something like that. Yeah, it will print you are voting or something like that. Yeah. So during the competition, I already set up my free BSD machine. You can see over here, and then you can run the binary. Yeah. So for this challenge, right, I solve it by mimic the whole binary logic into Python. So I convert all the C code into Python. So this 3 loop over here is actually the 3 for loop we just seen just now. So this 3 for loop, yeah, it's just line 17 to 32. And then yeah, so also the data, right? We need to get this data. So how do I get it? We can set breakpoint something like over here, 1C23. So C23, map. Oh, the screen is too big. Um, 3. Okay, so this 409DF0 is the data value. So I'm not sure if it's it. Yeah, it's data value. Oops. I just no. Yeah, I just overlooked. You can see the first one is 01036000. Yeah, so it's only 20, something like that. And we need to dump this data value out. So I think I use dump memory just 09 tf0, and then need to calculate how many, but it's okay, we can just IE110 dump it. Yeah, this could be the data value we need. I'm not sure if I dump this correctly because I cross check. I think I dump it incorrectly. How many bytes are here? It's okay, I can open the correct one. Yeah, I dump it incorrectly. Let's fix that. Let's just, is it upon? This is not. Let me move over to. yeah, it should be it, I think. Three C. Let's try. Oh, it's weird. Let me look deep into it. It's better. What if I just oh, it's, you can see it actually got 180 in front of it. I didn't realize it. Yeah, so this is the value we want, and we need to dump it. So yeah, just do the dump function we do. Deal with this. Yeah, so you can see the value we dump, the correct value, and yeah, I can see 3C64. So 3C64. Yeah. So after that, we just need to, yeah, moving back to the script. So we just pass the dump value into the binary, and then this is the key we just seen, and this is the CT. So what we did for this for loop is we will range, we will look through all the flag character, possible flag character, and then from 0 to 256, and then we will just input it one by one, see if the output is equal to the string over here. And one thing to note is I noticed that there is more than one possibility input that will result into the same output. So I concat it into a potential string, and then we need to figure out the most suitable character. Yeah. So for example, we already know that another. You can see the potential. The next character got 2, which is 5 in hex or hash. So obviously the most suitable character is hash. So we need to choose the hash, and the next got G and E. So we need to figure out which one is the best. So after some trial and error, I get the flag, which it is another hearing, or is this it? Yeah. So this is it for challenge number 4. Yeah. So thank you for coming for this sharing session. So we will see you in the next sharing session. Thank you.